Good afternoon, gentlemen. Welcome to Mustang Academy. Now I come back with differentiation, the second part of it. Now I'll be covering the lecture in following topics. Recap of part one. After that, differentiation of infinite series. We'll see how infinite series are differentiated. Differentiation of parametric function. Derivation of a function with respect to another function. Logarithmic differentiation and successive differentiation. So now let's move on to the topic name. Okay, in last chapter, I've told you about the concept of differentiation. What is differentiation? Differentiation is nothing but basically you're finding the slope of the curve at that very point. That is differentiation. Rules of differentiation, like I told you, f of x plus g of x d by dx of f of x plus d by dx of g of x. When you differentiate function with a constant, then constant come outside, and then you differentiate with the function. Differentiation of two functions which are product of each other, d by dx of u v d by dx of u plus u d by dx of v, d by dx of v by u. Rules of differentiation of some standard functions. After that we took some standard function like sin x, cos x, tan x, inverse function, sin inverse of x, cos inverse of x, tan inverse of x, sec, cosec, cot, all those things we have taken. Chain rule, in which fog or gog, f of g of x or g of f of x, when there are two functions and one function is function of another, so that is fog. So we have studied that. Implicit functions, in which there are two x and y. It is an equation in form of f of x and y. For example, x squared plus 2xy plus y cube is equal to 42. This is a implicit function and differentiation of it. And important substitution. We learned about some important substitution during differentiation. So yeah, talking about substitution, let's take this first example. If you have been given y is equal to tan inverse of x upon 1 plus root of 1 minus x squared, you have to find dy by dx 1 minus x squared. So either we take sine of x or cos of x. I am taking x is equal to sine theta. Therefore this function y becomes tan inverse of sine theta upon 1 plus root of 1 minus sine squared theta. Okay, then this becomes y is equal to tan inverse of sine theta upon 1 plus root of cos squared theta, nothing but cos theta. Okay, now we know. Now let us go back to trigonometry and use the half angle formula. So sine theta is equal to 2 sine of theta by 2 cos of theta by 2 upon 1 plus cos theta. Half angle is 2 cos squared theta by 2. Okay, just remember those formulas. Okay, so this is tan inverse of tan of theta by 2, which is theta by 2. So if x is equal to sine theta, so theta is equal to sine inverse of x. This is y. So your y becomes 1 upon 2 sine inverse of x. So dy by dx would be equal to 1 upon 2 d upon dx of sine inverse of x, which is nothing but 1 upon 2 1 upon root of 1 minus x squared. Okay, so this is your answer. I did it by using substitution. Okay, now let's go to the next part, differentiation of an infinite series. Okay, if there is a series which is infinite and it is recurring, for example, y is equal to sine of x plus root of sine of x plus root of sine of x up till infinity. So how will we do it? So let us see. We can write this as y is equal to root of sine of x plus y, because it is coming to the same thing. So y is equal to root of sine of x plus y. Now we can square both the sides. Let us square both the sides. Squaring both sides, y squared is equal to sine of x plus y. Y squared is equal to sine of x plus y. Now differentiating with respect to x. Now let us differentiate it with respect to x. So 2y dy by dx Differential of y squared, sine of x is cos of x plus dy by dx. So dy by dx 2y minus dy by dx is equal to cos of x. So dy by dx 2y minus 1 is equal to cos of x. So dy by dx is equal to cos of x upon 2y minus 1. This is your final result. So this is how an infinite series is differentiated. You have to take the function and see what is recurring and put in terms of original function y. See, x is equal to f of t, x is in terms of expressed in terms of t. Similarly, y is also a function of t, so both have got the same parameter. Now you have to find dy by dx. So we can obtain by differentiating y with respect to t and x respect to t, then we get dy by dx. Okay, let us take example 3. X is equal to 380 upon 1 plus t cube. Y is equal to 380 squared upon 1 plus t cube. Now we have to find dy by dx. So dy by dx would be dy by dt upon dx by dt. So we have to find separately. So dy by dt is equal to d upon dt or d squared upon 1 plus t cube. After that is equal to 1 plus t cube 680 minus 380 squared 3t squared, the whole upon 1 plus t cube the whole square. This would be equal to 680 plus 6a t raised to 4 minus 9a t raised to 4, the whole upon 1 plus t cube the whole square. So this is equal to 680 minus 3a t raised to 4 upon 1 plus t cube the whole square. This is dy by, so dy by dt is 680 minus 380 raised to 4 upon 1 plus t cube the whole square. Now let us see what is dx by dt. So this would be 1 plus t cube 3a minus 3at 3t squared, the whole upon 1 plus t cube the whole square. So this would be 3a plus 3a t cube minus 9a t cube, the whole upon 1 plus t cube the whole square, dx by dt. So dx by dt would be 3a minus 6at cube upon 1 plus t cube the whole square. Now dy by dx would be dy by dt, the whole upon dx by dt. Now let us substitute the values. 6at minus 3at raised to 4, the whole upon 1 plus t cube the whole square, the whole upon 3a minus 6at cube, the whole upon 1 plus t cube the whole square. So this will get, we can again take 3 dy by dx would be equal to 6at minus 3at raised to 4 upon 3a minus 6a t cube. 3 gets cancelled, so this would be 2t minus t raised to 4 upon 1 minus t cube. So this is your final. And now differentiation of one function with respect to another function. Now we have got function u and v. So we have to find du by dv. For example 4, when u is equal to tan inverse of root of 1 plus x squared minus 1 upon x with respect to, so first you find u with respect to v. So du by dv is equal to du by dx upon dv by dx. This is u. So u is equal to tan inverse of root of 1 plus x squared minus 1, the whole upon x. So again we will substitute this and get the answer. So let, because it is plus, so we take x is equal to tan theta. U is equal to tan inverse of root of 1 plus tan squared theta minus 1 upon tan theta. U is equal to tan inverse of root of 1 plus tan squared of theta minus 1 the whole upon tan theta. So 1 plus tan squared theta sec squared theta, tan inverse of root of sec squared theta minus 1 upon tan theta. So this would be tan inverse of sec theta minus 1 upon tan theta. So this would be 1 minus cos theta the whole upon cos theta sin theta upon cos theta. 1 minus cos theta. 1 minus cos theta is equal to 2 sin squared theta by 2. And sin theta is 2 sin theta by 2 cos theta by 2. So tan inverse of tan of theta by 2. So this is equal to theta by u is equal to, so du by dx. So if we have taken the substitution as x is equal to tan theta, so tan inverse of x is equal to theta. Tan inverse of x is equal to theta. So theta by 2 is 1 upon 2 tan inverse of x. So is equal to 1 upon 2 tan inverse of x d by dx. So now we differentiated. So du by dx is equal to 1 upon 2 1 upon 1 plus x squared. Now v is equal to 2x root of 1 minus x squared. 2x into root of 1 minus x squared. The whole upon, that is tan inverse of, the whole upon 1 minus 2x squared. So here also you can substitute it as sin theta or cos theta. Okay. So let us substitute it as sin theta. So v becomes tan inverse of 2 sin theta root of 1 minus sin squared theta the whole upon 1 minus 2 sin squared theta. V is equal to tan inverse of 2 sin theta sin squared theta upon 1 minus 2 sin squared theta. This becomes V is equal to tan inverse of 2 sin theta cos theta. 1 minus sin squared theta is cos squared theta, root goes, so it becomes cos theta. And 1 minus sin squared theta would be equal to cos 2 theta. Okay, so V is equal to cos 2 theta. This is nothing but sin 2 theta. So V is equal to tan inverse of sin 2 theta upon cos 2 theta, which is nothing but tan 2 theta. V is equal to tan inverse of tan 2 theta. So V is equal to 2 theta. Since we have taken x is equal to sin theta, x is equal to sin theta, sin inverse of x is equal to theta. Therefore, 2 theta would be equal to 2 sin inverse of x. So V is equal to 2 sin inverse of x. So dV by dx is equal to 2 1 upon root of 1 minus x squared. So differentiation of tan inverse of root of 1 plus x squared minus 1 upon x with respect to tan inverse of 2x 1 minus x squared upon 1 minus 2x would be equal to 1 upon 2 1 upon 1 plus x squared 1 upon 1 plus x squared the whole upon 2 into 1 upon root of 1 minus x squared. So this would be 1 upon 4 the whole upon root of 1 minus x squared upon 1 plus x squared. This is your answer. So, but if it is given that find the derivative of tan inverse of root of 1 plus x squared minus 1 upon x with respect to tan inverse of 2x root of 1 minus x squared upon 1 minus 2x at x is equal to 0. If solution I have done, I have solved it, but if they have asked at x is equal to 0, what is the value of that slope derivative at x is equal to 0? So this is your answer. Then at x is equal to 0, you can put 1 upon 4 root of 1 minus 0 squared upon 1 plus 0 squared. This is equal to 1 upon 4. So if they have asked at x is equal to 0, then your answer is 1 by 4. But if they have not asked at any specific point, then your derivative is 1 by 4 root of 1 minus x squared upon 1 plus x squared. Successive differentiation. Now let us see successive differentiation. Successive differentiation means second order derivative, second order differentiation, third order differentiation, and so on. For example, the differential of distance with respect to time of first order. So that is ds by dt is velocity, v, speed. The second order differential of the same, for example, ds by dt is equal to velocity. It is a first order derivative. So d2s, if I want to take dv by dt, so rate of change of velocity with respect to time, which is nothing but acceleration, which is d upon dt of ds by dt. So this will be d2s by dt2. Again, if you want to take the differential of acceleration, d upon dt of d2s by dt2, this will be d3s by dt3, which is nothing but jerk. Okay, a lot of motion given in a very small time. So this is a successive differentiation. Now let us do it mathematically. Y is equal to x plus e raised to t. Find d2y by dt2. So we get y is equal to x plus e raised to t, differentiating with respect to x. So dy by dt is equal to dx with respect to x. So dy by dx is equal to 1 d by dx of x is 1 plus e raised to x. E raised to x. So differential of e raised to x is e raised to x. d2y by dx2 will be equal to d upon dx of 1 plus e raised to x would be nothing but e raised to x. So d2y by dx2 would be equal to e raised to x. So that one will go. Okay, so this is successive differentiation. Now one part is left, which is logarithmic differentiation. So let us see logarithmic differentiation. So let us see some of the important formulas logarithmic which we'll be using in solving the problem. So log of mn is equal to log of m plus log of n. Log of m by n will be equal to log of m minus log of n. Log of m raised to n will be equal to n log m. So these are some of the rules of logarithms which we'll be using. I just stated through. So let's take an example. Y is equal to e raised to x plus e raised to x plus e raised to x. Now you have to find dy by dx. Okay, so again the same thing, the series is repeating. It is an infinite series. Remember the first problem we did, infinite series. So we will take it as y is equal to e raised to x plus y. I can very much write it. So let us take log on both sides. Log on both sides. We will get log of y is equal to log of e raised to x plus y. So log of y is equal to x plus y log e, which is equal to 1. So log of y is equal to x plus y. Log of y is equal to x plus y. Now we differentiate with respect to x. Differentiating with respect to x. D upon dx of log of y is equal to d upon dx of x plus y, which is nothing but 1 upon y. Dy by dx is equal to 1 plus dy by dx. Dy by dx, you can take it as common. Dy by dx is equal to 1 upon y minus 1 is equal to 1, which can be written as dy by dx into 1 minus y upon y is equal to 1, or dy by dx is equal to y upon 1 minus y. So this is your. So these are some of the These are all the types that will be there in your NDA examination or your 12th examination, but there will be different problems of all these types. Okay, so I've told you about 10 to 12 different types of problems that are going to come. So it is up to you to practice. The more you practice, the more your concept will be there, get clearer and better. So that's it for derivative. This is end of topic 1 and 2. I'll be getting application of derivatives to you very shortly. Thank you.